So this is going to be Tetris in Python with Pygame. Now this is a pretty advanced tutorial. A lot of the stuff I do in here assumes that you already have a basic knowledge of Python, you kind of know some of the syntax, and you're not a complete beginner. That being said, if you are a complete beginner, feel free to watch through, see what you might understand. You're probably going to learn something along the way. It just might be a little bit confusing because I'm kind of going to speed through a few things that I would consider like trivial right now, okay? So first step for this tutorial series is you guys have to download and install Pygame because that's the module we're going to be using. So I will put a link in the description and a card in the top right hand corner here to go and do that. I have a video, it's pretty quick, and it kind of goes through any errors you might run through when installing Pygame. So watch that first and then come back here. Okay, so let's just give a quick preview of what our game is going to look like. So this is Tetris. I didn't go too fancy with the graphics. I pretty much just want to make sure that we get everything functional here, and then you guys can play around and change stuff later on if you want to. But yeah, this is a fully functioning game. You can see it's just like standard Tetris. We have different colors, shapes are falling down the screen, shows us our next shape, and there we go, the road just cleared. So that's all I'm going to show you for right now because I want to get into actually coding, okay? So pretty much what we're going to be doing in this first tutorial is we're going to be working a bit in the main function. We're going to be creating the grid. We're going to be talking about formatting shapes, all the basic stuff, just setting up for the rest of the tutorials. So the first step, and what I need you guys to do, is you're going to download kind of like a starter file, okay? And that's just because if you see here, I scroll through my file, I got a lot of lists, I got a few things set up here, and you know what, I could go through and type them all out, but that's just a waste of a video because it takes a long time. So to save yourself time and to save me some time, what I'm going to do is just put a link in the description. It's a pastebin link. Click that link and download this code. It's just going to be all this. It just has all the functions that we're going to need for this. And then it has these shape formats, which I'm going to talk about in just a minute. So go do that. If for some reason pastebin's not working, let me know in the comments and I'll find another way to give it to you. But I'm also going to put it in the pinned comment so that you can just copy and paste it from there as well. I do recommend you check the indentation on it though, because sometimes it messes up on pastebin and in the comments. Okay, so now that you've got that downloaded, we're working on that. I'm going to be working in PyCharm. If you don't know about PyCharm, don't worry about it. You can just use IDLE, but this is just going to save me a bit of time because it auto-completes variables. It does some cool stuff, so that's what I'm going to be working in. Feel free to work in PyCharm, feel free to work in whatever text editor you want. Just know that that's what I'm using. It doesn't make a difference, but some of the stuff I do in here, you might not be able to do in IDLE or Sublime Text or whatever you guys are going to use, okay? So we've got that all the way, we've got everything set up, and now we're ready to actually start coding and understanding what's going to be going on. So Tetris is a fairly complex game. You have shapes moving down the screen, they're rotating around, they're moving left and right. When they hit the bottom, they freeze in whatever position they're in, and then if you have a full row complete of like cubes, then that row clears and you keep going, and obviously you lose the game if you stack up too many blocks and it goes up or above the top of the screen, okay? So this first variables we need to set up is our screen width and our screen height. So we got 800, 700 here. The next ones are play width and play height. Now this is the actual red box that you guys saw. That's what these are representing. So since in Tetris we have a 10 by 20 grid, we need to make sure that our play width is exactly half of our play height so that we have perfect squares, right? So doing the math here, that makes it 30 width and 30 height per block. So that's our block size of 30, okay? So now this top left and top left X and top left Y, this represents the top left position of our actual play area. That's so when we start drawing blocks and we start checking for like collision and stuff like that, we just have these already set up and we don't have to deal with that. So the math is pretty straightforward. You guys could probably figure that out. You don't need me to explain that. Okay, shape formats. So these, and this is the longest part, this is why I got you guys to copy everything, is this is what's going to represent our shapes in Tetris. Now you see that I have multiple lists inside of lists in most cases. This is because each shape has possibly more than one rotation, right? So this is the standard rotation of the S shape, and that's actually what they're called in Tetris, like S, Z, I, O, whatever. And this is the second rotation, and these are the only two rotations or whatever that S can have. So that's why we have them in here. We have a 5 by 5 grid of periods, and then whatever there's a 0, that represents where the block actually exists, okay? So Z, you can scroll through, you can kind of look at them, and you can see for some of them, for example, the square. Well, it doesn't have any rotation. If you flip it, it's going to look the same. So we only have one list here. For J, however, though, we have 4, right? Because we can rotate in different ways. L, we also have 4. T, we have 4 as well, okay? After this, I create a list, and it just holds all of my shapes. So S, Z, I, just so that way I can really easily select shapes just by indexing them in the list, like 0 through 6. And shape colors here is the same thing. It just corresponds, like for example, if I did shape 0 and I did shape color 0, then that's going to be the color of shape 0, okay? Same thing with like 6. So shape 6, well, color list or shape color 6 is the color of that shape. So it just makes it really easy. We don't have to deal with dictionaries or anything like that, okay? All right, so now we've kind of gone through the like starter file, I'd say, and you can scroll down here, you can look at the function names. I'm not going to explain them because most of them are pretty straightforward, and I'll talk about them when we start coding them anyways. But we do have a class here. Now this class is going to be the main kind of data structure, if you want to call it, for our game. And this is going to represent, or this class is going to represent different pieces. So the reason we have the class is because we're going to call this a bunch of times, and it's pretty much just going to hold the information like X, Y, width, height for our piece. So let's actually start coding this now. So I'm just going to create my initialization function or method. And this is actually the only method that I'm going to have. So I need another underscore, just butchered that. And pretty much what this is going to have is going to have an X, a Y, and then it's going to have a shape, okay? And that's the only information we need for this, and I'll show you why. So we'll say self.x equals x, self.y is equal to y, self.shape is equal to shape. And then what we're going to do here now is we want the color and we want the rotation. So self.color, well, I was already talking about this. Self.color is just equal to whatever the index of this shape is in this color list. So what we can do is we can do shape underscore colors, square brackets, and then shapes.index, and whatever shape we were given. So if we're given the shape S, well, let's just find it in the shape list, whatever index that is, well, that's the color of our shape. Pretty straightforward. And then we're going to do a rotation. So rotation, this is going to be set default to 0. And this is so that whenever we click the up arrow key, we can just add 1 to this rotation, and that will represent what shape we're actually going to be showing. Because again, remember, this shape list is a multi-dimensional list. It has, you can see here, like in this case, 4 lists within it, okay? All right, create grid. I don't know if we want to do this one yet. You know what? Actually, let's go ahead and do this one. It's not too complicated. So the way that I'm going to represent the grid in Tetris, so that 10 by 20 grid, is just by creating a list full of colors, okay? So we're going to have a 2-dimensional list, and within that second dimension, it's going to represent a bunch of colors, okay? So I'll show you just by coding and kind of talking about it after. Say grid is equal to, and then another square bracket here for X in range 20. And don't worry, I'll explain this in 1 second, and then we'll say for X in range 10, okay? Except here, we're just going to do 0, 0, 0. Okay, so what I've just done here, this is like the Python way to create lists, okay, list comprehension. We're going to create one list for every row in our grid. So since we have 20 rows, we want to create 20 sublists, and each of these like sublists or whatever 2-dimensional lists is going to have a bunch of colors in it. How many colors is it going to have? Well, it's going to have 10 colors because we have 10 squares in each row. We have 20 rows, so that's the way it works. These X's you could replace with underscores because we don't really care about the actual variable. We just need to do this that many times. Now 0, 0, 0, 0, or 0, 0, 0, yeah, I think that's right. Anyways, that's just block. It stands for block. And the way we're going to draw the grid is simply by looping through this grid, which we're going to return, and just drawing each color. So it makes it pretty straightforward, okay? Now, the only thing that we have to do here, though, is we have this locked position argument. Now, locked position, well, right now we've created a blank grid. What if there's already blocks that have been placed in our grid? So like they've already fallen, they're static now, they're not moving. Well, we need to also draw those. So to draw those, we're going to check if any of the positions in locked position are not like, or whatever positions are in locked position, we're going to get that color and we're going to change the corresponding value in the grid. I'll show that just by kind of coding it here. So for I in range, I'm going to do the length of grid, And again, this is going to give us 20 because the length of grid, well, it's 20 of these, right? Okay, so for I in range, len of grid, for j in range, and then we'll say the len of grid I, because now we're in this list, so now we're going to do whatever the length of that list is, okay? I'm going to say if this, so if j, comma I, because j is our x value, I is our y value, because rows are represented by I, and the columns are represented by j, in locked position. And just so you know, locked pause, it stands for locked position. It's also a dictionary, so you can see that it's a blank dictionary here, and each position, so like for example, if I had like 1 1, is going to be set equal to a color, and the color could be something like 25500, okay? And we're going to talk about that and create that later, but that's just something you need to know for now, okay? So if ji in locked position, so if that key exists, let's figure out what that key is. So that key is going to be equal to, well, locked position, or what the value is, sorry, associated with that key, ji. Now we're going to change whatever the current grid position is here. So for grid ij is equal to c, okay? I know this might seem kind of complicated, but pretty much we're just looking through this grid, and we're going to find the corresponding position to the locked position and just change that color in the grid so that later when we draw it, we get an accurate grid, okay? And you guys will see how this all kind of plays out later if it seems a bit confusing now, okay? And then we're just going to return that grid to wherever we're calling it from, okay? So that's one part done. Now we can move down and we can go into draw window, which is actually, let's do get shape. This one's really easy, okay? So this is literally a one-liner, return random dot, actually, what is it called here? I gotta have a look. I think it's random dot choose, random dot choice. That's what it is, random dot choice. And then we're gonna be given a shape list. So we'll say shape. Actually, let's just, what do I call it up here? Sorry guys, shape. Random dot choice shapes. All this is gonna do is it's gonna pick one of these shapes, and it's just going to give it to us so that when we need to create like a new shape falling down the screen or whatever, that's all we have to do, okay? So get shape, random.choice. That one's really easy, okay? Next one, draw grid. All right, so what we're going to do is we're going to be passed a surface, and the surface is obviously what we're going to be drawing on. So we're going to start by just changing the surface, surface.win, surface.fill with color. In this case, the color is going to be black, okay? Surface.fill is 0, 0, 0. All right, next thing we're going to do is we're just going to draw like a title on the thing. So the way we have to do this, we first have to start by initializing the font object. So I think we do pygame.font.init, okay? This just means we're setting up font and we're getting ready to draw to the screen. We're going to create a font. It's going to say font is equal to pygame.font.sys, capital SYS font. And then we need the font name. I'm a Comic Sans guy, so I'm gonna use that, Comic Sans. Size of the font, I believe. Yeah, size of the font, we're gonna do 60, okay? So the way you wanna set up your own font, you wanna change this, just change this to any font. You can look up fonts on the Pygame website, and then just give it a size. If you know the name of a font, type it in here. It probably exists in Pygame, all right? So now we're gonna need to set up a label. So I'm gonna say label is equal to font.render. And then in here, we need the text that we're going to render. In this case, I'm going to call Tetris. We need our anti-aliasing of 1. And then I believe we need a color. In this case, I'm going to make it white. Okay. So text, anti-aliasing, just set this 1. I don't know why you need to set this 1, but just set it 1. And then whatever color you want your label to be. Okay, now that we've got the label, we need to draw this label on the screen. So let's blit it. Not win. I'm used to typing win. Surface.blit. And then in this case, we're going to blit the label. Where do we want to blit it? Well, now we want to figure out where the middle of the screen is. So we could just hard code this in, but if we ever want to change the dimensions of our screen, we want this to just automatically kind of adapt to that. So we're going to do top left X plus play width over 2, okay? And that's going to give us the middle of the screen. If you don't understand that, let me know and I can explain it to you in the comments down below, okay? Now we're going to subtract this, sorry, this isn't actually done yet, by the width of the label, because this is going to matter. Depending on how long the label is, it's going to determine where we place it on the screen. So we're going to get the width of the label and we're going to divide that by 2. Okay, so now we need to do the Y. Well, the Y is pretty easy. We can just statically type this in because it's from the top of the screen. So I'm just going to give it, I think like 50 is what I typed in, 30, okay? and that should put it in the middle of the screen. And I can explain that to any of you guys that might not understand it. If you just leave a comment, because I don't want to waste too much time, because I think a lot of people might understand that. So for I in range now, the len of grid, because now we're going to start drawing all the grid objects onto the screen. So we created a grid. We know how that kind of format works. We're going to say for j in range, the len of grid I, same as before. And then we're going to do Pygame dot draw dot rectangle, and then in this case we're going to draw on the surface, and then we're going to go grid I j, okay, and then top underscore left. I need to put this in, what do you call it, brackets here, top underscore left. So I just need to scroll over, top left underscore x plus j multiplied by 30, and I'll talk about this one in just a second how this works. And then top left y plus I multiplied by 30. Another bracket, and there we go. Now we just got to deal with this grid thing, so that means that we just now need to pass grid as well into our draw grid. Okay. The way this works, we're going to loop through every color within our grid. So this is the color, grid IJ, all right? This is the surface we're drawing it onto, and this is the position in which it's being drawn. Now we also just need to add two things here that I realized I forgot, because we need the x, y, we need a width, and we need height. So for width and height, well, that's equal to the block size, and block size once again. And you know what, we can even multiply this instead of by 30 by block size in case we ever decide to change that. So let's do that just to keep this nice and dynamic. And then if we keep going over here, the last thing we need is a fill. So we're just going to put comma 0 to make sure that we fill in the shape. We don't just draw like a border for it, okay? The way this works, we get our top left x, and we're going to figure out wherever we are, so which column we're in, multiply that by block size, and that's our x position. Same thing works for the y. With the starting y position plus whatever row we're in, multiplied by the block size, will give us the correct position to draw our cube in, okay? After we've done all that, we just need to update the screen, so pygame.display.update. And there we go. So there's actually one last thing we want to draw, and it's that red rectangle that you guys saw, and that kind of represented like the play area. So to draw that, we do pygame.draw.rect, and then surface, and then in this case, we're just going to actually, let's see here, do I want to dynamically type this in, or do I want to just statically draw it? So let's give it a color first of all of red, 0, 0, 0. Okay, and we're actually going to type it in dynamic, just in case we decide to change anything later. So top left x and top left y, and then the width. Oh, we actually already have all these variables, so we have the play underscore width and the play underscore height. And in this case, we're going to give it a border size of 4. Okay, and that's all for drawing the grid. We might come back to this later, but for now, that's it. Okay, so this just draws the actual grid. Draw grid, and I've added this. So, okay, we're just going to copy this part here, guys, that says draw grid, so surface.blit, this label, and I'm just going to move this in because I realize I have another function called draw window. So in draw window, what I'm going to do is surface.fill, whatever. Okay, so we're going to take surface and a grid, so I've just copied some of it from there. And then instead of updating the screen here, we're going to update the screen over here, and we're just going to call our draw grid what do you call it, function like this. Okay, so now if we want to draw the grid and we want to use this in another program, we could just copy and paste this function. We wouldn't have to kind of take it out of here. We wouldn't have to like dissect it. All right. Okay, so draw grid, again, this takes surface and this takes grid, and there we go. I believe that's working well. Okay, now that we've done that, we're going to start coding in the main and in main menu, and this is what we're going to finish off with in this tutorial, because I know we're almost at the 20-minute mark. Right, so what we're going to do in main now is we're going to set up a few variables. So the first variable we need is this locked positions, okay? And again, this is what we're passing up here into create grid. It's equal to a blank dictionary to set. In case we don't pass it, then we don't need it, okay? So locked positions equals blank. We're going to say grid is now equal to, well, create grid, because we already created that function with locked positions passed to it. We're going to create a variable called change underscore piece. It's going to be equal to false. We're going to make run equal to true. This is just for our while loop that we're going to use. We're going to say current piece is equal to get underscore shape. Okay, we're going to say next piece is equal to get shape as well. We're going to set up a clock object, and clock is equal to pygame.time.clock. And we're going to set a variable called fall time equal to 0. And those are all the variables that we need in our main function, already coded for us, okay? So now we're going to set up our while loop. This is our main game loop. We're going to say while run. First thing we need to do in our loop is for event in pygame.event.get. Then we say if event.type equals pygame.quit. Well, that means we need to quit the program. So the way that we can do that is just simply hitting run equals false. It's going to break us out of our while loop, and then we can deal with that afterwards. We're also going to add another event. This is a key down event. So if event.type equals pygame.keydown, like that, then we're going to check what specific key is actually hit. So let's go ahead and do this now. Can I get it over with? So I'm just going to type all the different keys, and then we'll go in and code that after. So we'll say if, what do you call it? Pygame.key equals, I believe that's what it is, or event.key, not pygame.key, my bad guys. Event.key equals pygame.k underscore capital K, k underscore left. We say if event.key equals pygame.k underscore right, like that. And then same thing with up and down. So if event.key equals pygame.k underscore down. And last one, k underscore up, okay? Okay, I don't know why that keeps happening. Okay, k underscore up, like that. Okay, so painfully after typing that, left, right, down, up, now we can go in here and we can kind of code what each of these is going to do. So if we're hitting left, we want to move our block left. If we're coding right, if we're hitting right, we want to move our block right. And if we're going down, we want to move down. If we're going up, we want to rotate our shape. That's what the main things are going to do in here. So if we want to move our piece left, well, we should change the x value leftwise, okay? So the way that we can do that is going to say current piece dot x minus equals 1. Now, I know you guys are looking at this right now. You're saying, okay, well, what the heck, man? So current piece is equal to get shape. And that's all it's equal to, get shape. Well, what is get shape? And it's just returning random.choice shapes. Now, this actually just made me realize the fact that our get shape thing needs to change a bit. That's because we need to actually create a piece in here. So we set up this lovely class up here and we weren't even using it. So piece, random.choice shapes is the last argument it takes. It also takes an x and a y value, right? So for the x and the y, well, the y is pretty straightforward. It's just going to be 0. The x has to be the middle of the screen. So we're going to give it 5. And for y, we're going to give it 0. Okay? And actually for y, we'll leave it 0 for now, but we might want to make it negative so that it kind of starts above the screen and then starts falling down. Okay? So we have, let's make sure this looks right, XY shape. Yeah. Okay, great. Okay, so that makes sense now, how we could change this x value. Same thing for right. I'm going to do current piece dot y, or dot x plus equals 1, like that. And for down, we're actually just going to type this in for now, but this is not exactly what's going to work. Y plus equals 1 to move downwards. And for up, well, we need to rotate the shape. So to rotate the shape, this is actually pretty easy. All we're going to do is current piece dot rotation plus equals 1, okay? Because when we change that rotation, well, that changes the actual image of the shape, okay? Now, this is all great, but the thing is, what if we're moving off the screen? Or what if this is not a valid position? Well, that's why we have a function called valid space. Now, valid space, we haven't yet coded, but I do have it in here somewhere, valid space. And what valid space is going to do is it's simply going to return if the current position that we're in is a valid space. So the way that I do this, and this is going to just make life a lot easier, if we're moving left, let's simply just change the piece as x, move it left 1, and then check if that's a valid position. And if it's not, well, then we can just add 1 and move it back to where it was. So we're going to say if not, and then valid space, and valid space is going to take 2 arguments. It's going to take the current piece, and it's going to take the grid, okay? Then let's just simply subtract or add 1 to our piece. So all this is saying is we're going to move left, but if for some reason moving left results in not a valid space, well, let's just add one and pretend like we didn't even move there. So we're not drawing it, we're not changing anything. So this is perfectly fine. And it's actually a really easy way to check things without having to checking if it's below this or above this or whatever, okay? So now next one here, we're gonna say if not valid space, and same thing, current piece with grid. Well, now in here, instead of adding one, we're just gonna subtract one because we were trying to move right. And there we go. Same thing with moving down, okay? So we're literally just gonna type the exact same thing. If not valid space, current piece, and grid. Well, now instead of adding one, we're just gonna subtract one, and this is from the y value this time. So it's like current piece dot y minus equals 1. Okay, so now for up. So when we change the rotation, we are changing the shape, okay? So it doesn't show this yet right now, like how we change the shape, but we're gonna do that later. So we can actually just call the exact same thing on rotation, because think about it. If we're fully on the right side with like the straight piece and we try to rotate, well, that could result in our piece being moved to the left or to the right. Or like there could be positions where it's on the left or it's on the right and it's not in the grid. So we do have to check for rotation if it is a valid space or not. So we'll say current piece, and then what else are we doing? Grid here. Okay, and then in this case, again, we'll just subtract 1 from rotation. So minus equals 1. And that should all work pretty well. Okay, so after we do that, we're gonna make sure that we remember to draw the grid. So in this while loop, we'll say, actually draw window. I'm gonna give it surface, and we're gonna give it grid. Now, this reminds me that I haven't yet created a Pygame surface. That's great. So let's do that. So here I'm just gonna say when equals Pygame.display.set_mode. In this case, I'm gonna give it, what is it? Screen width and screen height. So S width and S_height. And that's it for our display. We want to give this a caption now. So we'll say Pygame.display.set_caption. Yep. So let's just call this Tetris like that. And now we're going to just pass win into our main menu. We'll put win here. And then in main menu, we're going to call main. Okay. And we'll deal with main menu later. I don't feel like coding it right now. And it's not really important to like the main functionality of a game. So we can simply just do this. Okay. Main win like this, and if I put win here, then everything should work out. This says surface. Change this to say win in lower cases. Okay, so now we've effectively done draw grid, or draw window, draw grid, get shape, create grid. We've created a piece. We've gone through what all this stuff in the starter file does, and we are now at 27 minutes. Hey guys, and welcome back to part 2 of coding Tetris in Python with Pygame. So let's get right into it. In this video, we're going to be finishing a few other functions. We're going to be doing valid space, convert shape format. We're going to be coding a bit in the main, and we're also just going to be fixing a small mistake I made in the last video. So this code right here in draw grid, yes, this does draw our grid, but this is not what I intended this function to do, and I kind of just realized this when I was looking over the video and looking over the code. So we're just going to copy this code from draw grid, okay, delete it out of there, and we're just going to paste it down here at the bottom of draw window, okay? So now we just have this after we're splitting the label, we have whatever code we had within draw grid, okay? Because draw grid, what this actually was supposed to do is draw the lines for the grid. So I kind of got this mixed up while I was going through the tutorial. So we're going to finish draw grid now, and what this is going to do is it's going to draw those gray lines over top of all of our different colors so that we can kind of see where each block is and we can see the actual grid structure. So let's get started with this. Say SX, which stands for start X, is equal to top left X, okay, and then SY is equal to top left Y, like that. All right, and this is just so I don't have to keep typing top left X, top left Y. It just makes it a little bit shorter for us. Okay, now I'm just going to say, I'm going to set up a for loop. I'm going to say for I in range, and this is going to be the length of the grid, so how many rows we have. I'm going to say for J in range, and this one is now going to be the len of grid I, so how many columns in each row. And then here we're going to be drawing lines. Okay, so for every row we're going to draw a line. So pygame.draw.line, we need a surface. Let's give it a surface. We need a color. In this case, it's going to be gray. So gray color code standard is 128, 128, 128. And then we need 2 positions, okay? So the start position is going to be equal to SX, all right? And then SY plus, what do you call it? I believe, multiplied by block size. And I think that is actually correct. Okay. Now for the end position, well, it's going to be the same X value because we're just drawing, or actually it's going to be, let me just check here. Yeah, it's going to be a X value that is just equal to the width. So SX plus whatever the play width is. And then the Y value is going to be the same here because if you think about it, we're going to be at the same Y value each time. We're doing like, we're drawing a horizontal line. Every horizontal line is going to have the same 2 Y values and the X value is just going to be changed. Okay, so I'm just going to copy this and paste it in here now. Okay, oh, all right, I don't know why that did that, but we'll just go back like that, okay? So now what we're gonna do is we're just gonna do this, okay? So SX plus J multiplied by block size, okay? SY can actually just stay like this, okay? And then for SX, same thing, we're gonna SX plus J multiplied by block size, and J is again is our current column. And then this one, SY plus play underscore, oops, we need a plus sign here, plus play underscore height, like that, okay? And that should be drawing us, what do you call it, 20 vertical lines and then 10 horizontal lines down the screen, giving us a grid. And kind of the way that works is every time we loop through a new row, we're simply changing the Y value of what line we're drawing, and then these X values are going to stay static just at the left side and the right side of the screen. And then the way that we do it here is we have the X values that constantly are changing every column, and then the Y values are staying static, being the top of the screen and the bottom of the screen to draw the vertical lines. And that's what I wanted to do within this draw grid function. So now that's all kind of sorted out, and we fixed like a small mistake. Don't get me wrong, you can still have that other code up here, like it still works fine, but just in terms of what I actually wanted to do with these functions, that's the way we needed to fix it. Okay, so now that we've done that, what I want to start doing is getting into this convert shape format, okay? Now this is probably the most complicated function, I want to say, within our program. And what this is going to take as an argument or a parameter is just the shape. Now this is what I was talking about before. So when we have a shape, it looks something like this, right? So we have zeros and we have periods. Now this looks nice to us, like we can tell what kind of shape this is, but the computer has no idea. So how can we get this into a form that the computer can read? And ideally we want it to give us positions within the grid of where blocks exist. And then we're not going to give position if the block doesn't exist. So if there's a period like this, okay? And you'll see what I mean as we start coding this function. And that's what the goal of this function is to do, to take that information and put it into something that's actually useful to us. So we want a bunch of positions. That's the goal. From these like lists, we want to generate a list of positions, and then based on those positions, we can do things. We can check them, we can draw them, and so on. So I'm just going to create a list called format. Don't worry if it's a keyword, it'll just override it. We're going to say when we're given a shape, we're actually given a piece object. So I don't know why I'm calling it shape, but whatever, it's fine. So shape.shape, and then we can just do is equal to, and I'll talk about this in a second, shape.rotation modulus the length of shape.shape. Okay, so what this does is actually gives us the sublist that we need. So this needs to be spelled correctly. Don't know how I butchered that, but so bad. Okay, shape.shape. So if we look again here, whenever we're past a shape, we're actually past something like this, right? So we're past the shape object and its shape property. So right here looks something like this. Looks like the variable t, which would have a list full of lists. So we want to get the actual sublist. So which one? This list, right? That's the one we want. So the way we do that is by getting the shape rotation modulus the length of the shape. So for example, if our current rotation is 0, like we haven't rotated yet, then what's going to happen is we're going to have 0 modulus the length of shape. In this case, the length would be 4. So we get 0. So we're given this first shape. Now, if we have 1, we're given this. If we have 2, we're given this. If we have 3, we're given this. And if we have 4, then we go back and we get this one, okay? And it just keeps going and keeps going because modulus simply just gives us the remainder. So that's how we can tell what the actual current shape is within that main list, okay? Hope that makes sense. So now that we've done that, what we want to do is we want to set up a loop. And because we want to look through every row and every column, and then based on if there's a 0 or a period, we're going to do something. So we're going to say for I, comma, and because we want the line as well, in enumerate, right? And then format, okay? Because format is the list that contains like the actual zeros and ones, okay? We're just going to say row is equal to list of line. This just gives us a nice list format that we can deal with, making it easier for us. I'm going to say for j in, or j, comma, column, sorry, in enumerate, and now row. So now every row we're getting the current line, and then we're going to loop through the line and look for either a 0 or a period. So we're going to say if column, which is going to be, for example, if we have something like this, it's going to look like 0, 0. Okay, so this is what our row is going to look like. So when we start looping, j will be 0 and column will be a period, okay? Just in case you're kind of confused there. Okay, so for if column equals, and it's going to be string 0, then we know that we've hit like a position, like this cube exists here. So what we want to do is we want to add the position to our positions list. Now it's not so simple as just to add the current I and j value. We actually have to add something else. And I'll show you right now. I'm just going to type it out and then kind of talk about it, okay? So shape.x plus j, and then shape.y plus I, okay? So this is our x value. It's the current value of the shape, because if the shape is already moving down the screen or it's moving left and right, well, we need to add that to whatever the j value is, so whatever column we're in within this list, okay? And then same thing with the y value, so whatever the current y value is of our shape, we're going to add whatever column or whatever row, sorry, we're now in as for the y value, okay? And that is the positions that we need in these positions list. Okay, so now that we've done that, we just have to modify these positions slightly. We just have to give them an offset, okay? And I'll talk about why why we have to do this. So for I pause in enumerate positions, okay? Then we're going to say positions I is equal to, and then this is going to be the current position, okay? So we just need to put this in a tuple because that's the way we're going to give it. Pause 0 minus 2, and pause 1 minus 4. Okay, so now let's break this down and kind of talk about exactly what's going on. So we start off blank list positions. We're just getting the actual shape within this list. So for example, we would get something like this, okay? And then we're looping through it, and where am I? Sorry. And we're pretty much just checking if a 0 exists in each position of that shape, okay? If that exists, then we're going to add that position into our list. And the way we do that is simply by getting the x plus whatever the current column is that we're looping through, and whatever the current row is plus y, okay? Now that we've got that, the issue is that if we look here, we're going to get something like, for a position list here, we'll get something like 3, 1, and then we'll get 3, 2, we'll get 3, 3, and we'll get 3, 4, okay? Now the issue with that is we're adding the current x value plus these 2 periods and the O. So we need to remove these kind of trailing periods, right? Because that's going to result in our positions being all offsetted to the right by too much. Same thing with these y values, okay? Because when we're counting this row, we're saying, well, this is 1 lower than this row. So our current y value, say it was 0, and we're adding to it. Now instead of just adding 1, we're going to be adding 2. So everything's going to be offset down. So the way that we can kind of fix this is just by offsetting by a constant. And by offsetting, I'm just going to take every x value that we've added and subtract 2 from it, and every y value that we've added and subtract 4 from it. Now what this is going to do is simply just move everything to the left and up, so that when we are displaying it, it's just more accurate to the screen, okay? You guys can see what's going to happen if you don't offset this, and you'll notice that you kind of run into a few errors. So just run with me on this area, and just kind of, you should see how this works later on, okay? Okay, so now that we've converted the shape format, I want to go and code valid space now, okay? So valid space is going to take 2 parameters, shape and grid, all right? And we're going to check the grid to see if we're moving into a valid space. So what I'm going to do here is I'm going to create 2 lists. Okay, I'm going to say accepted. How do you spell accepted? Accepted underscore pause. So these are just going to be the positions that are actually valid, okay, is equal to, and just flow with me on this, I'll talk about it in a second, for ji, and then within this list for j in range 10. This is similar to what we did in the last tutorial, and then for I in range 20. Okay, so this is really similar to the way that we created the grid. We're just getting every single possible position for a 10 by 20 grid, okay, and we're just adding it in a tuple in accepted positions. Okay, that's great, but the thing is, I want to convert this into a one-dimensional list. So this is the way that we can do this and make all the positions, but now how do we flatten this list? So this is actually how you do this, okay? So accepted pos is going to be equal to, and this is one way, there's many, j for sub in accepted positions, and then one more for j in sub, okay? So what this is actually doing now is it's pretty much taking all the positions in our list and just adding it into a one-dimensional list. And then we're just overriding this list with that. So see if you guys can understand that. If not, don't worry about it. Just know that all this does is simply flatten this list. So we go from looking something like this, what do you call it, like 0, 1, and then having another list embedded. I'm just trying to show an example here, 2, 3. So we go from that to something that kind of looks like this. And we just have the positions in it now. So we don't have those sublists, and this just makes it a lot easier to loop through, okay? So now we just have 0, 1, 2, 3, rather than having these embedded lists full of other tuples, okay? That's all we're doing with this line. Okay, so after we do that, what we want to do is we want to get all these positions, or we're going to get the shape, and we're going to convert it into our positions, right? Because remember, whenever we get a shape, it looks something like this. It means nothing to us. We need to first convert it into positions before we can compare it against other positions in our grid. So we're going to use this convert shape format grid, or convert shape format. We're going to pass it the shape, and we're just going to store this in a variable, and I guess we're going to call it, what should we call it? Formatted, okay? Because I guess that makes sense. We formatted our shape, so now we can use this and kind of compare it against accepted positions. So here we're going to have a list that looks like something with a bunch of positions in it, and then this one we're going to have a list that has a bunch of positions in it. So you might see where we're going here in terms of how to compare these things, okay? Okay, so now that we've done that, we've kind of got all our data ready to check. This is the really easy part. So we're just going to say for position in formatted, and all we're going to do now is just check if this position exists within accepted positions, because accepted position is every position that we're allowed to have, right? So we're going to say if pos not in accepted position, and this is an important part, pos 1 is greater than -1, return false, and then otherwise, so if we make it through that loop, that means we had all our positions accepted, we can return true. Okay, so let's talk about this really quickly. The reason I have this if pos 1, so the y value is greater than -1, is because when we give this offset of 4, what ends up happening is we get some, when we spawn in our shapes, they're going to spawn above the screen. Now we actually want this because we don't want our shape to show up on the screen. We want it to start falling before it's actually seen. So typically this means a y position is going to start at like -1 or -2. So the thing is, while it's falling, we're checking if it's in a valid position, right? But the thing is, it's not going to be in a valid position if it's negative. So we just want to make sure that we're only asking if it's in a valid position if the y value is greater than -1, so greater than or equal to 0, okay? And this is just a really easy way to tell us, well, are we on the grid or not? So let's give an example. Say we're trying to move left, and we're already at the edge of the screen. So that means we're going to have an x value of -1. Well, that position of -1, whatever y value, is not going to be in this accepted position list. So when we try this, we're going to return false, and it's not going to allow us to move left. And that is the whole point of that. And now, okay, what am I doing here? Okay, so I also just want to modify this part up here. So I have for j I in range, for j in range, if I in range 20, I want to just change something here. Okay, so what I'm going to do actually is I'm going to say if grid I j equals and then the color 0, 0, 0. Okay, so this is an important part. I was kind of waiting. I was kind of thinking about this. So pretty much we're only going to add this position into our accepted position if it's empty, which actually makes a lot of sense. Because think about it, if we already have a color in that position, then that's not a valid position. We can't move into where a piece already exists. So what this condition does is it says, okay, well, we're only adding this position now if this is true. So if ij is true, then we're good. We can add the position. If it's not 0, 0, 0, that means something exists in there. So that's why we're not going to add it into our accepted positions. Okay, so I know this looks kind of confusing because I'm doing like a bunch of embedded for loops. This just saves us a few lines. And it's kind of a cool way to create a list in one liner. It's like the Python-y way. So I figured I'd do that for most of the stuff in here. Okay, so now that we've done that, what else can we code? Well, you know what? While we're here, we can code check lost. All right, this one's a really easy function. This is just simply going to check if any of the positions are above the screen. So if we hit y value of 0, then we know that we're above the screen and we've actually lost. So the way to do this is we're going to say for pause in positions, because what this is going to do is we're going to pass a list of positions. So we're going to get every pause now in the position. We're going to say xy is equal to pause, which is simply just splitting up the tuple because we know we're going to get something that looks in the form of like 3, 4. Okay, and we're going to say if y is less than 1, so equal to 0 or greater, then return true, else, or we don't even need an else, let's say return false down here. So if every position is less than or greater than y, or whatever, 1, then we will return false because we haven't lost yet. Otherwise, we're returning true. Okay, so we're almost getting there. Now I want to go down to the main, and I want to finish coding up some stuff in here. So last time we kind of just left it at this, like moving pieces around, whatever. But we have these variables, okay? So change piece, next piece, clock, fall time that we're not using. So what I'm going to do now is I'm going to show you guys how we can actually move our shape down our screen at like a regular time interval. So I'm going to create a variable here actually called false speed. And this is how long it's going to take before each shape starts falling, okay? So we'll talk about how to do this. I'm going to start coding it now. So pretty much we're going to say up here, and I didn't do this before, but just follow along, grid equals create grid based on locked positions. The reason we're doing this, I know we already created grid up here, is because every time that we move, we have a chance to be adding something to locked positions. We're going to do that later. Because, for example, if we hit the bottom of the screen, well, now locked position is going to be equal to something else because it's going to have a new shape in it. So we need to constantly update the grid so that when we're drawing it to the screen, we get like an updated version. So that's why I'm doing that up here, okay? I also need to, actually, I don't think I need to do that here. We need to add to fall time, okay? So the way we're going to add to fall time, because this is going to track how long since like the last loop ran, is by using this clock object that I set up here, okay? So before I add to that, after here, I'm going to do clock.tick, and then I'm going to add this, and I'll talk about this after I do it. So clock.get underscore raw time, like that, okay? So the way that this works is this raw time actually gets the amount of time since this last clock.tick. So when I first add, it's going to be 0 because we haven't yet ticked the clock. And the next iteration, it's going to see how long it took this while loop to run. And then it's going to simply add that amount, okay? So it's actually going to give us real time. This means that this should technically run at the exact same speed on everyone's computer and everyone's machine. Because I know when I use FPS, FPS is dependent on kind of the speed of, your actual computer sometimes, like the way I did it in other games. So this is a better way to do it. So now what I'm going to do is, since I've now incremented the fall time, and this is going to be given to us in milliseconds, so like 1 second would be 1,000, that's that number, and our fall speed is in, well, 0.27. So what I need to do is I have to say if fall time divided by 1,000 is greater than fall speed, then what we're going to do is we're going to reset fall time equal to 0, and we're going to add 1 to the current y value. So, which means we're moving down the piece 1. So this is going to automatically now move our piece down. Now the thing is, what if our piece will hit the bottom of the screen, or what if it's moving into a position we can't move into? So this is the same thing we've kind of done in here. What we're going to do is we're going to say again, if not valid position or valid space, whatever, given the current piece and our grid, I believe at least grid, okay, then, and actually we're going to check one other condition, and our current piece dot y is greater than 0. So this means that we're not at like the top of the screen, because the same thing with negative values, all right, is greater than 0. Then what we're going to do is we're going to subtract 1 from the current piece. So y minus equal 1, because that means, well, we moved into an invalid position. So let's move back up 1 and pretend like that never happened. And we're just going to say change piece is equal to true. Now the reason I'm setting change piece equal to true, because think about it, right? If we're moving down, we move into a position that's not valid. Well, we know we didn't move left or right off the screen because we were moving down. That means we must have either hit the bottom of the screen or hit another piece. So in that instance, we need to stop moving this piece and we need to change it. And what changing piece is going to do, we're going to do that later, is simply going to lock all the positions, what they're currently in, and then it's going to make this next piece generate down the screen. And I'll show you that in a second, but this is kind of the way to check it, and it's the easier way, then you don't have to check like the Y values and all that stuff, okay? All right, so now that we've done that, let's move down here to the bottom of main, and let's start adding a few things. Okay, so what I want to do down here, I want to say shape positions, so shape underscore pause, is equal to convert shape format current piece. Because what we're going to do now is we're going to check all the positions of the piece moving down to see if, well, we've hit the ground or to see if we need to lock it, okay? So, and we're going to add all that color to the grid so that when we're drawing it, we actually see the piece. Because right now we have the piece, but we don't add its color into the grid, so we're not actually going to see it show up. So we first need to add it to the grid so we can draw it and we can see it moving. So to do that, we're going to say for I in range, the len of shape positions, okay? What we're going to do here, we're going to say x, y equals shape positions of I, because that's the current iteration, the current one we're looking through. We're going to say if y is greater than -1, so this means that we're not above the screen. Then we say grid y x equals current piece dot color, okay? Because remember, the grid stores a bunch of different colors, so all we're doing in the grid is giving different colors, and based on that position in the grid, so yx, which is going to be this shape, all the shape positions, we're going to draw that color. Now the reason again I have this -1 is because imagine that we're at the top of the screen and we try to draw it, or we're above the screen. We have a position with a -y value. So if we throw -1, we're not actually going to get an error in grid here, but it's going to end up looking like it's at the bottom of the screen and then moving to the top, and it's just going to look weird. If you guys want to see what it looks like without this, just remove this condition and you'll see that I have it added in. Okay, so now what we're going to do is we're going to check this change piece variable. So I put it up here, change piece. This means that we've hit the bottom or we've hit something. What we're going to do now is we're going to update locked positions. And this one I'm going to start talking about locked positions. Okay, so for pause actually in shape positions. All right, we're going to say P is equal to pause 0, pause 1. All right, I don't know why I do this, but I think there's a reason for it. So let's just run with it. And we're going to say locked positions P is equal to current piece dot color. Okay, so what is this? Well, locked positions is going to be a dictionary in a form like this, all right? It's going to have a tuple in here. It's going to have a position, so like 1, 2, colon, and then we're going to have a color, and the color is going to be another tuple, but RGB values, okay? So for example, 255.00. The reason we have this is so that when we pass locked positions into our grid like this, all right, we can get each of those positions in the grid and then update the color of grid. So every time that we have like a locked position, and a locked position, it simply means our piece is no longer moving, it's hit the bottom of the screen and we're onto a new piece, we can get the position and we can get the color, and then we can update the grid based on that, and we can keep that in there, okay? And that's the way that locked position works. So it's a dictionary with the key of a position and the value of a color. All right, that's kind of like the data structure for that. Now what we're going to do after this, after we update our locked positions and we add positions to it, we're going to say current piece equals next piece. Okay, so we're just going to change that. And now since we've said current piece is now equal to next piece, well, we need to update next piece. So let's get a new shape, because we're just moving forward with the game. And now, of course, we got to say change piece equals false, because we're on to a new piece that's going to spawn at the top of the screen. Okay, and I think that is about it. What we also want to do actually is we're going to check if we lost the game. And I think I do this after draw window. I don't think it really matters, but we're just going to say if check lost based on, what do you call it, locked positions. Okay, so these are all the positions of the shapes. Then we're just going to say run is equal to false, and that's going to break us out of this while loop. And you know what, while we're here, let's indent out and let's just go Pygame dot what is it? I think it's .display.quit or something. Yeah, .display.quit. So we're actually just exiting out of our game. Now, up until this point, I actually have not tested my code. Now, I know some of you probably think I'm insane because we've already written like 300 lines of code and we haven't tested any of it. The reason I haven't done this is because I wanted to test this in between videos, figure out what the errors were so that I didn't waste too much time fixing all of them. So I'm going to go through a few errors that we have now and show you what happens when I run the code. So I'm just going to delete that because that was a fix that I made. And pretty much you can see that we crash right away and we actually get a for I in range, none type has no length. Now the reason we get this, and this happens down in the main, is because in convert shape formats, somehow I managed to forget to return positions. Now this is really important because the whole goal of this function, well, was to generate this list of positions, and we did that fine, but we forgot to return them. So pretty easy error to fix, so return positions. Now, again, we run this, we're like, okay, everything looks good. No, there's another issue, all right? So just watch, if I try to go off the screen, you can see that we get a unsupported operand for current piece because I forgot to put a Y or an X here. So let's go down to main, let's fix this. What line are we on? 262. 262 current piece dot X. Yeah, that would be important. Okay, now I know there's a few other errors. So this one, current piece minus equals, let's change this to an X. Current piece minus equals, wow, I really messed up on this a lot. Okay, dot rotation minus equal 1. Okay, so this is rotation. And let's see, anything else? Let's run the program. See, okay, we're getting another issue here. So if we have valid space current, okay, so I just messed up and a bracket here. So let's go line 265. Here we are. So we're just gonna take this quotation mark, or what am I saying, quotation mark bracket, and just put it there. And all should be good now. Let's see. We go down to the bottom of the screen. Okay, we get another. And let's just play this for 1 sec, see if we can run into any errors. Okay, so we're rotating fine. We can't move off the screen. And all looks to be doing okay. All right, so that's a good sign for now. Let's leave that so it doesn't look like there's any issues. If you find any, I'd probably end up fixing them in future videos, so don't stress about it. Okay. So now that we've done all this, what we need to do next is a few things, all right? So we need to deal with this draw next shape, clear rows, draw text middle, what other functions do I have? And I think that's about it. And we're also gonna deal with main menu, kind of starting the game, finishing the game, and all that stuff. So what I first wanna do actually is I want to deal with draw next shape, and then I'm going to do clear rows just because clear rows is kind of complicated. So draw next shape, what this is going to do is it's just going to draw the next shape kind of off the screen and show us what it is. Because in Tetris, typically it shows you like the next shape, the next few shapes. So yeah, now this seems pretty straightforward, like just draw the shape. It's actually kind of long because we have to, once again, get this list, turn it into positions that we can use. And yeah, it gets a bit complicated. So what we're going to do is we're also going to set up a font in here. So we're going to say font equals pygame.font.sys font. And here we're going to do Comic Sans again, because you guys know I love Comic Sans. Comic Sans size, let's do 30. And let's render this font. Okay, so label equals font.render. Text for this is going to be next shape. Okay. Feel free to add a colon or something if you guys want. Anti-aliasing 1, text color white, 255, 255, 255. Okay, basically we've already been through that. Okay, now we need to figure out where we're gonna draw this, this label, okay? So let's do the same thing we've done before. We're gonna say sx is equal to top left x plus the play width, and then we're gonna say sy is equal to top left y plus the play underscore height. Actually, we want play height. We're gonna say play height divided by 2. Okay, now what we're gonna do is this is gonna give us like to the right. Maybe I can just run this and show you guys. It's gonna give us where my mouse is right here, like a position kind of similar to here. So what we want, or actually here. So what we want to do is we want to add a constant to this so that we move to the right a bit. So this constant we're just going to hard code in, and we can change this and play with it if we want it to be like move more to the right or more to the left. So to move more to the right, we're going to add 50. And then to kind of make this look a little bit better, we're just going to actually subtract 100 from this height so we can move a bit higher up on the screen. Play with these constants if you guys want it to look a bit different. Okay, so now that we've got that, what we're going to do is we're going to format, we're going to say format is equal to shape. And same thing, we need the actual shape, so not just like that main list. We're going to shape.rotation modulus the length of shape like that. Okay, so this is the exact same thing that we did in format whatever. Okay, you guys know what function I'm talking about, and I've lost myself here. Okay, just to get the actual like sublist that we need. Okay, so now you might say, well, what are you doing here? We already have like a function that does this for us. Don't worry about it, just follow along, because this is a bit different the way that I'm going to do things. Okay, so I'm going to say for I, comma, line in enumerate, all right, and then row, or actually format, sorry. And we're going to do the same thing here. We're going to convert row into list. This is really similar to the other function, except we're going to do one major change, and you'll see that for row equals list line, we're going to say for j, comma, what do you want to call it, column in enumerate row this time, and exact same condition if column equals 0. What we're going to do here, instead of adding some position to list, is we're going to draw something. And this is why I didn't want to use the other function that gives us list of positions, because I don't care about the position within the grid. I just care when we should draw something or not, because this doesn't matter. It's not going to be moving. We just want to draw like a constant image on the right side of this, or a static image on the right side of the screen that we can just look at. Okay. So what we do here is we're going to say pygame.draw.rect. So .draw.rect. We need a surface. We pass the surface in. We need a color. It's going to be the shape color. Okay. And then we need our position to draw. So SX. And then in this case, we're going to have to, since we're drawing each cube, right? We're not just drawing the whole shape, plus J multiplied by 30. And then we're going to do the same thing with Y. So SY plus I multiplied by 30. And we can actually just change this to, let's change this to block size to be a bit more dynamic. Okay, so instead of 30 block size, just in case we decide to change the dimensions of our screen later on. And then we need a width and a height, and that is going to be block size, and we want this filled in, so comma 0. Okay, so what we've done here is really similar to what we've already done. We're just going to be drawing these blocks according to where they show up, like in this list, based on the initial X position plus like a changed kind of position or whatever. Okay. Anyways, I think that's about it for this. Oh, we need to actually bullet the label now. So we created this label, but we haven't actually drawn it on the screen yet. So let's do this. So we say surface dot bullet label. Change this to a period. Okay, and then we need a position. What's our position going to be? Well, we're actually just going to do SX plus 10 and SY minus 30. Okay. Again, play around with these constants, guys. If you want your thing to look a bit different, be more centered, whatever. I don't go like too crazy on cosmetics here. I just want everything to work and look decent. I assume you guys can mess around with it, all right? Okay, so now that we've done that, we've drawn the next shape. Well, we actually need to call this function. So within draw window, we're going to call draw next shape as well. So where should we call this? Let's see. Let's call it before we draw the grid. Draw next shape, or actually we can't call it in here. Where we need to call this is in the main, because we only have next shape within the main. So right when we're drawing draw window, we're actually just going to call draw next shape, because we need to give it the next shape. So it's going to be next piece, and then the grid. Is that what it takes? Or it takes a surface? Yeah, surface. Okay, so let me just go check this to make sure. And our surface is not called surface, is it? It's called win. Okay, so in draw next shape, yeah, we take a shape and a surface. Okay, so that should work fine. You know what? Let's actually just test this now and see if this is working. And we're not showing up. We're not drawing this surface. I believe it is because draw window, draw next shape. Okay, so what we need to do actually is this. Draw next shape. We're going to draw after draw window, and we're just going to update the display in here. So pygame.display.update, and then if we go to draw window, just remove this display update, and this should work. There we go. So now we're getting next shape on the side. The reason that wasn't working is because we were pretty much drawing over top of the next shape every time that we drew the window. So now that's working fine. We have our next shape showing up. And what else do we need to do? I'm really delaying trying to go to this clear rows function because this is really complicated, but I think we're going to have to do this next. Okay, so clear rows. In Tetris, obviously, if we create a full row, we need to clear that row. And then, so that's the only way the user can win, obviously, yeah? So the way to do this is probably a lot easier than the way I'm going to do it, but try to follow along because this is the only way I can kind of get to work, and this is probably the hardest part of the actual game, okay? So we're going to take grid and we're going to take locked positions. And what we're going to do is we're going to set up a few things here. Just follow along with me. I'll try to explain as I go. So we're going to say inc, which is an increment equals 0, for I in range the len of grid, -1, -1. Okay, and we're actually just going to subtract 1 from this too. What this is going to do is it's going to loop through our grid backwards. So it's going to start at the 20th row and it's going to move up to the 19th row. Okay. I'm going to say the current row is equal to grid I, all right, and we're going to say if the color 0, 0, 0 is not in our row, let's clear it, okay? So we're going to add 1 to inc. Don't worry, I'm going to explain this after, guys, just follow along, okay? Say ind equals I, and we're going to say for j in range the length of row. What we're going to do is we're going to try to delete locked square brackets current position, which is going to be ji, and then if this doesn't work, I'm going to accept and continue. Okay, so let's just talk about what I just did here because I kind of went fast, and there's another part to this function, don't worry. So the way this is going to work is we're going to say we're going to loop through the grid backwards. We're going to set row equal to every row in our grid, so that we're looping through. And the way that we know if the row should be cleared is if 0, 0, 0 does not exist, because if 0, 0, 0 does not exist, that means there's no black squares in our row, which means it's completely filled with shapes or completely filled with cube objects or whatever, okay? So we know we can clear it. So the way to clear it now, and don't worry about these variables, I'll talk about that in a second, is to get every position in that row. To do that, we need to loop through j in the row, and we're already at the current row, so we know that I is just going to stay static. Change j and try to delete this from locked positions, because now what we're doing is the locked positions need to be removed. So when we del these, since locked position is a dictionary and it's mutable, we can actually just change it within here, and that's how we delete those keys and those colors from the grid. Okay, so after we delete that all, what we need to do is we need to shift every row. So what's happening now, and I think I'm actually just going to pull out like a little, I have a drawing tablet and just start using this to kind of explain some things because it's pretty complex. So just give me 1 second. All right, so what we need to do is we need to shift every row. So if we delete like the bottom row, every row above that row needs to move down by 1. So if I go to, let's see this, and delete this, okay? So you can see if I have a grid, all right? And it looks something like this. We're just going to do like a very basic like 3x3 grid, okay, just to save us some time. Let's say that we want to clear this row down here. So these are full of colors, right? So if we clear this row, then what happens is we get rid of all these, and then any positions that were above it, so let's draw something like this. Now this is here. Well, currently this is floating, right? Because if we've cleared all these positions down here, so we got rid of those, this is floating. So this needs to move down 1. So how can we go about doing that? And the thing is, every other row needs to shift down by 1 as well. But now let's talk about like a potential issue we might run into. So if I delete all that, and let's say we have a grid that looks like this, okay, and there's a color here. If we delete this row, the grid actually now in our memory only looks like this, all right? It's only this top portion because we've deleted an entire row out of the grid. So yeah, we can shift everything down by 1, but now we're left with the grid that's 1 less than the other one. So what we want to do is we need to add another row at the top here so that our grid stays the same size. Because if you delete an entire row, well, you're deleting the row, right? So you need to add back the other positions at the top because everything's shifting down by 1. So really the way it works is you delete this, and then this whole thing moves down, and then you add a row at top like this, okay? So that you're back to your continual grid. I hope that makes sense. That's kind of the only way I can really explain it to you guys in terms of how we shift things, and now I'm going to do it in code, all right? Okay, So leave a comment if you guys are confused about that, because I'll try to explain it in a better way, but it's just kind of like a confusing topic in general. Okay, so now what we're going to do, we're going to say if inc is greater than 0. Okay, we're going to say, so this means that we've shifted and we've removed at least one row. And I'll talk about the case in which we move 2 rows in 1 second, okay? I'm going to say for key in, and just follow what this is. This is going to be kind of confusing. List of locked positions. So locked, because we just pass in locked there, okay? And then we're going to say key equals lambda. I'll explain what this does in a second. x1. And I think that's about it. And we're actually just going to reverse this. -1. Okay. So for every key in our sorted list of locked positions based on the y value is what this does. So given a list that looks like this, so if you have like 0, 1, 0, 0, okay? This is a very basic list. This could be an example of locked positions list, okay? What we're going to do is we're going to sort this list. And the way we sort it is based on this number here, this y value. And this is what this key equals lambda x, x1 does. You don't have to understand that. This is just a really kind of complex way to sort a list. What we're going to do is we're going to now make it look like this, 0, 0, 0, 1. And the way we do that is so that we get all the positions that have the same y value in like the correct order, okay? And you'll see why we need that when we start coding, okay? So I'm going to say x, y equals key, because again, remember key is a tuple. And then we're going to say if y is less than ind, we're going to say new key is equal to x comma y plus inc, and then locked new key equals locked.pop key. Okay, let's dissect this now, all right? Because this is, I told you guys this was kind of confusing. So what we're doing now is we want to shift every single position in the grid down, because when we delete a row, everything above that needs to move down. So the first part is pretty straightforward, okay? So x, y equals key. So we're simply getting the x and y position of each key in locked positions. And remember, locked positions has a key, and then corresponding with that is a color. Okay, straightforward. Now what we're going to do is we're going to say if y is less than int. And what that means is if the y value of our key is above the current index of the row that we removed. So if we remove, for example, row 17, then only things that are above that are going to move down. We don't need to move anything below row 17 down because we didn't remove anything after row 17, right? And I'm going to show this in a drawing in just a second. Okay, so if that happens, what we're going to do is we're going to change a key. We're going to get a new key. We're going to say it's equal to the current x value, but we're going to increment this by a certain value. So we're going to add to the y value to shift it down. And then what we're going to do is we're going to rewrite, we're going to create a new key in locked position, which can have the same color value as the last key. Again, this is what this gives us, the last current color value, but it's equal to this position, right? So I'll explain why this works now, kind of with a drawing, and why I needed to look at this backwards, okay? Because when we're looking at from bottom to top, there's a reason for that, all right? And I might butcher the explanation, but just kind of bear with me here for a second, because this is important to understand why this works. And this is the most complex thing, and this is actually very useful. You might want to use this a lot, like shifting positions in a dictionary or in a list. Okay, so if I go back to my little drawing thing here, and I go like this. Okay, so let's create a grid over here. Let's make it a few more rows this time, just for a better explanation. So 1, 2, 3, 4. Okay, I'll make it a 4x4. Okay. And you guys can see my fancy drawing skills. Let's make this a row. So let's say we have a row like this. Okay, so it's green, make orange. Orange didn't work. Okay, so green can stay there. Orange, like this, and like this. And then we'll add some more colors. Let's do like blue up here and up here. Okay, so obviously this is the row that needs to be cleared that my mouse is going over right now, okay? So this is the row that needs to be cleared. What happens when we clear this row? Okay, so we've looked from the bottom of the list up, and we found, if we're looking at row like 4. Now we're looking at row 3, and we say row 3 needs to be cleared. Okay, so it's cleared, so we delete everything out of row 3, right? This row is now gone. So our grid in memory just looks like this and this. So what we need to do now is need to shift these positions down. But we don't want to shift these positions. So that's why we're getting that IND, so that we know which positions in our grid to shift. So we delete that row, and then what we're doing is we're adding 1 and shifting all these positions down. Okay, that's a straightforward example. Let's get rid of this and let's do this now, okay? So let's say when we add our, I don't know, shape, whatever, to our grid, we end up getting something that looks like this, okay? 2 rows that need to be shifted down. Now what we have to do is we have to delete this row and this row. Now here's the thing, we delete this row, we delete this row. How many rows does this now need to move down? Well, this needs to move down 2 rows. So how do we know how many rows to move this down? How many rows to move everything else above it down? Well, that is based on our, increment here. And that's why whenever we delete a row, we add 1 to increment, because we know that we have to now shift it down another row, okay? And that's kind of the way that this works, if that makes sense. Now, the reason that we go through and we look at things backwards is so we don't overwrite existing rows. Now, this is another complex thing, okay? You probably don't have to really understand this that much, but anyways, okay, so let's just, it's not gonna let me undo, okay, that's fine. So we have this, right? Now, here's the thing. If we started looking at it from the top down to the bottom, what would happen is we would, so let's, I actually have to add another row for this example to make sense. Okay, so if I add another row and I say, well, okay, boom, let's add a color, let's pick yellow, right? Let's say we have a position here and we have a position here, right? So that means this position, and this position all need to move down. So here's the thing, if I move this one down by 2, all right, or if I move it down by 1 or whatever, it could possibly overwrite this existing position. And we don't want that to happen. So why we have to start looking at it from the bottom is so that when we start moving everything down, we move the lowest most things down first. So that way, when we then change this, there's no possible way we're going to overwrite this right here, okay? Because remember, if you, in a dictionary, if you change a key and the key already exists, well, you're just going to overwrite that key. So that's why we start looking at it from the bottom. If that doesn't make sense, don't worry, just that's for any of you, that's why, okay? Because I want to make sure I explain everything and you guys understand at least on some level why I'm doing what I'm doing. Okay, so that's it for the explanation of clear rows. Now let's call the function. So when are we going to call clear rows? Now this is actually an interesting call. We could call this function every loop, but we're only going to call this when our change piece hits the ground. Now, the reason for this is because you could possibly be moving down the screen, and at some point, the grid would have a full row before your shape actually hit the ground. Now, we obviously know the way in Tetris, when you're moving down the grid, until you like land or you stay static, we're not clearing anything. So that's why we're only going to call this if we are about to change the piece. So clear rows, what does clear rows take again? I'm going to say it probably takes grid and locked positions, maybe? Yeah, grid and locked positions. Okay, so pass it the grid, and we'll pass it locked positions, okay? So then we're checking, whenever we're changing the piece, if we should clear a row. And this can clear multiple rows at once, okay? I'm going to be showing you guys a few different things. So in the last video I mentioned I was going to be doing more cosmetic stuff. So that is true in this video. I'm going to be showing you how to do the main menu screen, how to draw text in the middle of the screen, how to make things look a little bit better. And I'm also going to be adding a little bit of functionality to the game in terms of making the piece fall faster as it moves, or as time moves forward. So obviously we want the game to get more difficult as time goes on. So what we're going to do that is increase the speed at which the piece falls down the screen. It's pretty easy. I'll show you how to do that. I'm going to be adding score, and we're going to be displaying that score. And that's probably about it for this game. So the first thing I want to show you is how to add the piece falling faster. So to do this, we need to create a variable in our main here. And I'm just going to make this equal to, what do we want to say? Fall, or let's say level underscore time, okay? And this is going to just represent how much time has passed, and it's going to be similar to fall time, and level is just because as we increase speed, like the level is going up, kind of whatever. Okay, so say level time plus equals clock dot get underscore raw time, and we're going to do exactly what we did with making the piece move down the screen, except we're just going to change the speed at which it moves down the screen. So what I'm going to do here is we're going to make another if statement. I'm simply going to say if level underscore time divided by 1000 is greater than, and then you can put in whatever time you want here. Now I'm going to do 5 seconds. So every 5 seconds we increase the speed, okay? And then we can decide what we want to increase the speed by. So I'm going to say level underscore time. We need to first reset this back to 0 so that we continue to do this. And then what I'm going to actually do here is I'm going to say if level underscore time is greater than, and we want to put like a terminal velocity here. So at what speed do we stop increasing the time? Because we can't get to a negative fall speed, otherwise you're just going to instantly fall, and we don't want it to get too fast that the game's unplayable, so we need to pick a speed. Now a good speed that I kind of found was 0.12, because anything faster than that is like pretty fast, but I mean you guys can play with that and change that around. It's a really easy number just to fix, right? And then if we're greater than that, we're just simply going to subtract a value from level underscore time. Now this value, the magnitude, so the size of this value that you're subtracting, is going to determine like how quickly you increase the speed, as well as obviously the time. So I put originally 0.01, and I mean depending on how long it takes you to play a Tetris game, this is pretty fast, because that means after 50 seconds you're already going to be down to 0.17, which is very quick and almost at terminal velocity. So I recommend you do 0.005. That means it'll take about a minute and 40 seconds before you're going to be close to reaching this terminal velocity, which might be good if you're playing Tetris for a decent amount of time. Okay, so you guys can play with those numbers, but that is going to move it down faster. I would show you, but it's going to take like a decent amount of time for it to continue moving faster, so just play with that, okay? Just trust me. All right, the next thing we want to do is add score. So we need to first create a score variable. I'm going to say score is equal to 0, like that. And incrementing score is pretty simple. I'm going to say, and you guys can make this whatever you want, whenever we clear a row, I'm going to add 10 to our score, because you had 10 pieces or 10 cubes or whatever that you cleared, okay? So actually, the way that we need to do this is we're going to return a value from clear rows, which is going to be equal to score. Now I'm going to go to clear rows, and in here, I'm simply just going to return inc, okay? And inc is the increment, so how many rows that we actually ended up clearing. So if we clear more than one row, we're going to get a value of 2. We can multiply that by whatever our score increment's going to be, and then yeah, we can just add that to the score. So this is pretty straightforward. If we go to clear rows, we're going to say score is equal to clear rows multiplied by 10. All right, or actually not equal to, we're gonna have to say plus equal to clear rows plus 10. Now what we need to do is we need to display this score on the screen somewhere where the user can see it, and we're actually going to save this score as well when we lose the game. Okay, so the way that we can display this is we're going to have to do it in draw window, but we're going to have to pass this score to draw window. So after our grid object, we're going to pass score like that, and we're going to go to draw window, and we're simply going to add another parameter here, score, like that. Now I'm just going to set it equal to 0 as a default parameter, so in case we call it somewhere else and we forget to add that score, that's fine, we don't need that. So what I'm going to do now is I'm actually going to go to draw next shape, and at draw next shape you can see if I run the program quickly here, it shows us like a little text object, okay? Now I want to get this similar text object, so I'm just going to copy this font, the label SX, SY, and I'm just going to bring it down here into draw window. Now it doesn't really matter where you draw it, I'm just going to plop it in the middle here, and obviously I'm going to change this from next shape to be score. Now we need to obviously display what the actual score is, so we can just say plus str score like that, and that should be displaying for us. Okay, so now we have SX and SY, which is giving us the play area, I believe, or no, this is actually the position in which we wanted to draw it. Okay, so what I'm going to do is I'm going to say now win dot blit, or is it surface dot blit our text object, which is the label. And then where do we want to draw it? So we want to draw SX, SY. Now I'm just going to have a look up here to see where I did it here. So SX plus 10, SY minus 30. So what I might want to do is we can add plus 10 to this, so it's aligned, but then we're going to subtract, or actually add to the y so it's lower. So I'm going to add, let's say like 80, like that. So let's test this out and see if it's working. Score, so it's not low enough. So we'll add this, do 120 and see where we're getting it now. Score, again, not low enough. Let's go 160. And again, you guys can play with these numbers. Score equals 0, perfect. And then maybe we'll just add 10 more pixels here so it's more in the center. And, you know, whatever, that's good enough for me. Okay, good. So that is working well. So we've got the score and we're moving down faster. Now what else do we need to do? What we need to do now is work in main menu and figure out what happens when we actually lose the game. So we have this check lost, and all this simply does is just quit the game for us when that happens. But we want to do something else when we lose, and we want to display something to the screen. So actually, before I go in main menu, I'm going to go up here to a function that I told you guys, I need to get rid of that I was going to finish, which is draw text in middle. Now this is going to take a surface, text, and what else do we want? Let's say size and color. Okay, so surface, text, size, color. This way you can use this in another function, or sorry, in another program, and you can use it multiple times with whatever text, size, and color you want. So we're going to set up a font. We're going to say font equals pygame.font.sys font. By now you probably know this. I'm just going to pick Comic Sans. We're going to make it equal to size, and bold is going to be equal to true. Now you can make this false if you want, or just omit it completely and then it won't make it bold. Pretty straightforward. Make a label. Label is equal to, again, font.render. And then we're going to say text, 1 for anti-aliasing, and color, like this. Okay, now we'll just simply draw this in the middle of the screen. So to do this, we'll say surface.blit, label, comma, and now we're just going to do a little bit of math here. So top underscore left underscore x plus play underscore width divided by 2, not 3, minus, and we're going to get the label width. And the way we do this, I don't believe I've actually done this yet, is get underscore width. I think I'm just going to check. Yeah, get width. And then the reason I have this in brackets because I'm going to divide this by 2 as well. And this will essentially give us the middle position where we should be drawing in terms of x coordinate. Okay, so now I'm going to give top underscore left y plus play underscore height divided by 2. Okay, and now same thing, minus label dot get underscore height in brackets and divided by 2. I don't know why I can't tab over here. Okay, divided by 2, and that should hopefully be working for us. Okay, so we can test that out in just a second. So we've got this, it's blitting now whatever text we want to the screen, so this makes it really easy for us to draw anything to the middle of the screen. So the first thing I want to draw to the middle of the screen is like a you lost message. So when it says you lost, what I want to do is draw, obviously, you lost, and tell them that. So let's say draw text middle, and then what do we want to draw? Well, let's simply draw what surface first actually that we need. So we'll say win, and then we're going to pass it text, and in this case we're going to say you lost, exclamation point. Size, let's go for 80. And color, let's go white. And obviously you guys can play around with that. Now after I draw that and I display the screen, or update the screen, pygame.display.update, just because we haven't called the window yet, draw window when we do this. Then what we're going to do is we're just going to delay. So we're going to say pygame.time.delay, and I'm just going to delay 1.5 seconds, just so once this comes up, the user has a second to look at it, because then we're going to move back into our main menu screen, which you'll see. Okay, so I'm just going to fast forward this until I lose, and then you guys can see that it's working. And there we go. So we got you lost, and then it delayed, and then just quit because I have this pygame.display.quit here, okay? So now what we're going to move to is main menu. Everything else is working. I told you guys it's not like super difficult, a lot of this stuff. And in main menu, what we're going to do now is we're just going to make it pop up whenever you start the game and whenever you lose. And it's just going to say hit any key to like move forward, to continue. Okay, so I'm just going to set up another game loop in here. So we're going to say run equals true while run. And this is going to be really similar to the loop we've done above. It's just a lot shorter. We're going to just draw in here without using a different function, just because we're not drawing very much. So it's not important that we, what do you call it, like update the screen with a defined function. So I'm just going to fill it with black just so we kind of are getting rid of everything. We're going to draw text middle, and what I'm going to do here is I'm going to say press any key to play, okay? And then we'll give this a size of 60 and a color of white once again. Okay, so that's being drawn in the middle. We'll update the display, so pygame.display.update like that. And then we're going to say for event in pygame.event.get, so similar to what we've already typed up top, we're going to say if event.type equals pygame.quit. We always want one of these, not quit queue. Then we are simply going to say run is equal to false, and then we can tab out here and we can just make sure that we are actually quitting the display, so .quit, and we'll get rid of this pygame.display.quit. And then we're going to add one more event, and this event is going to be a key down. So whenever they press any key on the keyboard, then that is going to move us forward, and we're simply going to call this main function where we'll play, and I'll explain how this kind of flows in just a second because it's really nice. Okay, so if event.type equals pygame dot all capitals key down, so if they hit any key, then what we're going to do is we're going to say main like that. Okay, and I believe that is about it. Okay, yeah, so let's see here. Pygame.display.quit looks correct. Okay, so the way this is going to work pretty much is when we run the game, we start by running main menu. So we run main menu, and then we go into this main loop where all it's going to do is just say press any key to play, and that's going to be drawn in the middle of the screen. Once that happens, we're going to check if they're hitting any key. If they hit any key, we're going to call main. In which case, sorry, let me close this so it's easier to see. If we hit main, then we go into the main game loop, and we go and we do this loop until eventually we lose. Once we lose, it displays you lost on the screen, makes this loop equal to false, which means it brings us back into this main menu loop, and we can play again by hitting any key. Pretty straightforward. Okay, so let's test this out and make sure this is working. Draw text missing one potential argument color. It's because I didn't give a surface, my bad. So let's just do win, and there we go. Okay, so press any key to play, press space, missing one main. Okay, sorry guys, and this is why we test our program. Okay, win, and now let's try. There we go, and now we're playing. It shows the score, and you guys can mess around with this. I haven't actually tested the score, so I'll just do this really quickly and see if I can clear a row without having to fast forward, which we may be able to do. Not using that one. Okay, let's see. There we go, and score is equal to 10. So the score system's working as well, and that's a relief because I hadn't even tested that before I put this in the video. Okay, perfect. Oh, when you press the X, brings you to press any key to play. If you press it again, you can do that. So if we wanted to change it, so when you hit the X key in the main thing and you want to close the game, then in the main loop here, sorry, what you're going to do instead of saying run equals false, just do pygame.display.quit. So you can do both. You can say run equals false, and then you can quit the display as well. Okay, so what's next? So I said we were going to save the score and potentially display that. So if we want to save the score, we're going to have to do something when we lose. So we're going to have to update like the current score, and we're going to use a text file to do this so that you can play multiple times. So what I'm going to do, I'm going to say new file, just create a new text file. I'm just going to call this scores.txt. Okay, and in here, I'm just going to put 0 as a default value. It's really important you put a default value to start, otherwise you might run into some issues. So just create a new text file, make sure it's in your directory with the script, okay? Now what I'm going to do is I'm going to create another function. It doesn't really matter where it goes. I'm going to say define update underscore score, and we're just going to give it score, okay? Now in here, what I'm going to do is I'm going to say with open, and this is how we're going to open our text file and like update the display with open scores.txt in R, so in read mode, and this actually needs to be in quotation marks as well. We are going to say do this as f, sorry, and I say f dot read lines like this, okay, and that'll be equal to lines is equal to f dot read lines. So that means our score is going to be, well, the first line, so score is equal to lines 0, and we're just going to add this dot strip so that we remove any like \ns, because if you don't know, in a text file, when you hit the next line, the way that it actually tracks that you have another line is it puts a character that looks like this on the line. It's invisible to you in the text file when you're viewing it, but when you read it in with code, you actually read in this character. So we just want to make sure we strip that off in case it is there. We're going to say score equals this, and then we'll just say, okay, so we've done that. And since we're tabbing out now, it's going to automatically close our file. What we're going to do now is we are going to open the file again, except in this time we're going to open it in write mode, which means we're going to overwrite whatever is in the file. And we're simply going to say if score is, I guess I'm going to change this to n score, standing for new score. If score is greater than n score, then we'll say f dot, and we'll say write lines, actually write, I think, and we'll simply put in str of score, which is this updated score. Otherwise, so if that's not true, we just have to write back the other score because we're clearing it when we open this with W mode, okay? So we're gonna say f.write, and then, or sorry, this is gonna be, what am I doing? N score. Yeah, sorry, so I kind of messed up in this way. It should be the other way around, but whatever. We're just checking if the original score is greater than the new score. If it is, we'll write the original score. Otherwise, we'll write the new score. So this works still, it's just not the way that I was thinking about it when I was kind of talking about that. Okay, so update score should work. And then, you know what, we can actually return, let's just return, actually, no, we don't need to return anything. So I haven't pre-written this yet, so I'm kind of still just going through how I want it to work. Okay, what we'll do here, after we set run equal to false, we'll say update score, and we'll give it whatever the current score is. And then this should be working in the scores.txt file. So let's run this. I'll fast forward through and make sure everything's working. Okay, so we got an error. Not supported between instances of string and int. Okay, so if score greater than n score. So we just mean we have to convert this to an int. So if we go back up to score, and where did I make this? Okay, score is going to be int score. Like that. Okay, and that should hopefully work because n score comes in as an int. And we'll run it one more time, one more fast forward. Sorry about that, guys. Okay, and another issue. Lines 0, list index out of range. Okay, I'm gonna have a look at this and come back. Okay, so this code is actually working just fine. The issue was that since last time when it crashed, we didn't end up writing anything into the file. So we had a blank file, and then we were going lines 0, where is it here? And obviously there was no line 0, so that crashed. But if you just add any number, so if I add 0 back in here to scores.txt and save it, then this works fine. Okay, so that's it for saving scores. Now we need to display those saved scores. So I'm kind of going to leave this up to you guys where you want to display it. I don't really know where I want to put my saved score, like high score, maybe on the left side of the screen. Doesn't really matter. So if I want to draw it on the left side of the screen, then I can do something like, we're going to have to first get this max score, right? So I'm going to have to make a new function called define max score, or last score, whatever you want to call it. And if you call max score, what we're going to do is we're just going to do the exact same thing we did here. So we can say with open scores.txt, score 0 equals line 0.strip, except in this time we're going to return score. Like that, okay? Now, what we can actually do here too is we can just simply replace this whole line with max score and just say score equals max score. Be the efficient way to do it. And I mean, feel free to do that if you want, or leave it the other way. Okay, so now we have something that's getting us max score. So how are we going to use this? Well, when we call main, I guess when we call main, or we can call main menu. Does it, like, you guys, if you want to draw it in the main menu, you can do that. Otherwise, just draw it in the main. To draw it in the main, all you're going to do is going to say like last score is equal to max score, which is going to be whatever is stored in that text file. And then to draw this, well, we're going to have to pass this again into when we're redrawing the window. So in draw window, I'm just going to say last score. We can go up to draw window again. We'll say last underscore score equals 0. And you're pretty much just going to copy exactly what we have here with this font and this blit. So let me just comment this and say this is current score, just so I can remember. I'm going to add a comment, say last score, high score, whatever you want to say here. And then we can just say score, and we can actually get rid of this font because we already defined it. We'll say high score equals and in this case, last underscore score. Okay, draw that to the screen. This is probably not where you want to draw it. You probably want to draw it top left X minus like some value, like minus 30, top left Y, maybe plus, I don't know, like 300 or something. So now we can see where this is actually going to draw if we check this out. So let's run this, press any key. So it's not obviously showing up where we want to. So we're gonna have to subtract more from this. So let's subtract like, I don't know, 100. And then this was plus too much. Let's do plus 200. And high score. So again, like you gotta move it over more. So we'll move over 200 this time and hopefully this works. Okay, so high score 0, score 0. And that's obviously because at the current moment we have no, our score is just 0 in that text file. Okay, so I think that is pretty much it for this video. If you guys have any questions, any errors, anything that I did in this video that you weren't sure about, leave a comment down below. I'll be sure to get back to you.